Hello, this is Dr. Oz. In this video, I would like to show you how to build a Monte Carlo simulation model. All right, let's start with entering the given parameters. All right, so here in this problem, we do know the selling price, and this number comes from marketing department. And we would like to sell this new purse for $249 per purse. Okay, and we have fixed cost to be able to launch this new line item. And let's say the fixed cost is $1 million for administration and marketing cost. Okay, 6 zeros. All right, so this is the fixed cost, and this is a variable price that I generate revenue based on. And this number is dollar per year. And also I have direct labor costs in this problem. And let's see what it is it is given to be a random number. Based on custom discrete distribution. When I say custom discrete, it's a discrete distribution because there are a limited number of outcomes. It's custom because the probabilities are calculated based on the historical data. So let's write it down here. Cost per unit, per person in this case, could be any number between $43, $44. Highlight these two. Right down corner, black cross, drag it down all the way till $47. And here are the probabilities. 0.1, 10%, 0.2, 20%, 0.4, 40%, 0.2, 20%, 0.1, 10%. These are the probabilities associated with each cost. Again, we should come up with this based on historical data. All right, so these are dollars, and these are probabilities or percentages for direct labor cost. Another cost I have here is parts cost. And the parts cost is based on uniform because all the probabilities are the same, continuous because it can get any value, it doesn't have to be integer or limited number of outcomes, continuous distribution. And for uniform continuous distribution, I need a lower bound as well as upper bound. So let's say the lower bound is $80. Again, this should come from the historical data. It's not percentages, these are dollars. So $80 per unit, dollar per unit. Upper bound is highest cost we see is $100, dollar per unit. Okay. Control C, Control V. So now another random variable here is the demand. Okay, and the demand is based on normal distribution. Okay, So let's say the demand is a normal distribution. A normal distribution has two parameters: average or mean and standard deviation. And here mean is 15,000 units and standard deviation is 4,500 units. All right, so I would like to change the original problem a little bit to make it even more realistic, because every single company, either they produce these things or they purchase or products and put them in their inventory. Let's say I have inventory of 25,000 units. So that will decide whether I can satisfy all the demand or not. Okay. So these are the given parameters. Now I would like to build my model based on these parameters. So first thing first, I always ask myself, what is the objective? So the objective of this model is maximize the profit. Why? Because if you look at the parameters that are given to us, we have positive number here. What do I mean by positive? It means that this is cash coming in. Revenue is cash coming in. However, also I have expenses such as fixed costs here, admin and marketing costs is an expense. Another one is this direct labor cost. It's an expense for my company, cash going out. Parts cost is another expense or cost for me because it's also cash going out. And so I need to consider these three costs and this revenue. So I can calculate my profit based on revenues. In this case, I have only one source of revenue minus expenses, which I have three different types of expenses. So I will calculate my objective function value right here, and I like to use green color to represent my objective. So the second step is, since I'm stuck here because I don't know the revenues, I don't know the expenses, I would like to go step by step and deal with each of them at once. So first I would like to focus on revenues so that I can then focus on expenses, then calculate my profit. So how would I calculate revenues? Revenues in general, unless you have a contract that gives you fixed amount of money, it depends on price times quantity. So when I say price times quantity, what do I mean by that? Price is selling price. P, maybe P sub selling. And quantity is not demand, not inventory, quantity sold. All right. So in this case, to be able to calculate this value, revenues, I need to calculate the quantity sold, because I know the demand is here, but also I know the inventory, which is supply side. However, I don't know really, this is my supply side. I don't really know what the quantity sold is. So that's why I'm stuck here. But price selling is here, so I know that. So to be able to handle this revenues part, I need to go quantity sold. Again, as you see, it's like puzzling. I need to calculate this so I can calculate that, so I can plug in here and so on. So let's calculate quantity sold. When I say quantity sold, what does it mean? It is the minimum of demand and supply. In this case, the demand is a random number, so I don't really know it exactly. And the supply is is something that is given here as an inventory. So I need to do that. So I don't know demand, so let's focus on demand since it's a random number. All right, step number 4, demand. Demand is based on normal distribution. So that's why I need to generate a number based on normal distribution. So how am I gonna do that? So what I'm going to do is, whenever you want to generate a random number based on normal distribution, not a probability, probability is norm dist, but I want to calculate number based on probability, not probability based on number. So since I want to calculate number based on a probability, I will use norm inverse function, basically taking the integral of normal distributions mass function. So what I'm gonna do is Excel is asking me the probability. So I would like to generate these probabilities randomly, rand function. Then comma, Excel is asking me the mean or average, is right here. Then Excel is asking me standard deviation, which is right there. Okay, so this will generate a random number for you, demand. So as you see, this random number though is not an integer, so I need to deal with that problem. However, so if this was a deterministic model, not a stochastic or simulation model, basically I would just use the average, right? Just plug in here 15,000 for demand. But in this case, I don't do that because I know that the demand will change based on external factor that I cannot consider. That's why based on the behavior of normal distribution, based on historical data, I just generate random numbers so many times to understand possible scenarios for my company. So it's like sensitivity analysis in a sense, but I can change more than 2 variables in this model. In sensitivity analysis, if you guys remember, maximum you can do is go two-way data table, which would allow you to change 2 parameters at the same time and observe 1 output. All right. So now if I want to eliminate the possibility of getting in non-integer values, I could use a run function here, and I can run this number, comma, to the nearest integer, which is I don't want to have any digits, so I put 0 here. Okay, that would eliminate your non-integer values problem. Whenever you press F9 or change something in Excel, those random numbers, as you see, does change. Okay, another issue with normal distribution is that it's bell curve. The tails goes to positive infinity and negative infinity. However, I know my demand cannot be negative. So to be able to eliminate that, I will use max function, and then I will compare this number that I generated versus 0. So whichever is greater will give me the positive number. So 0 comma the number that I generated. At the end I will put another parenthesis. So this will make sure that my number can never be 0, because less than 0, because if it's less than 0 it will take the maximum of negative number versus 0, which is 0. All right, awesome. So now I am done with demand. So next thing I need to do is supply, which I do know supply is not a random number, so 25,000. So I can calculate quantity sold by using min function. I will look at the minimum demand, comma, the supply. So whichever is lower will give me quantity sold. All right, in this case, 11,332, because my demand is lower than my supply. All right, so if I press F9, I may be able to get more than 25,000, which is not that likely. So I may not be able to. I will just try a few more times. So these are random numbers. I press F9. As you see, it looks like getting number greater than 25,000 is not that likely. And the reason is that 25,000 is more than 2 standard deviation away from 15,000. That means that the probability of that's happening is less than 5%. So if I will press this F9 20 plus times, I should be able to get 1. So, all right, I will try a little bit more. All right, still not there. Let's close. Okay, wow, this is really hard to get. All right, I guess I don't want to spend so much time on this because my supply is very high. But to make it easier, what you could do is put, let's say here, for fun, 16,000, and then you will see that the demand, when demand goes higher than 16,000, what happens? Right here, demand is 18,301, but my supply is only 16,000, so I can only sell 16,000 units, whichever is lower. Let's go back to the original number of 25,000 here. All right, so I'm done with quantity sold, so I can calculate my revenue, which is selling price times the quantity sold. Beautiful. So these are dollars, and these are per year, right? I just want to emphasize on that. So this is dollar per year. This is number of units. This is number of units. This is gonna be per year as well. All right, so now I'm done with revenues, so I need to calculate expenses so I can calculate the profit. All right, so expenses. How many expenses do I have? Three different types of expenses I have, which is fixed cost, admin cost, which is fixed cost plus direct labor cost plus parts costs. Okay, so do I know admin costs? Yes, it's given to me per year. That's good. However, I don't know direct labor because random number. All right, so I'm stuck here. I need to go and calculate direct labor costs. All right, so direct labor cost is going to be cost per unit, similar to revenue, which price times quantity. So in this case, price is gonna be cost associated with direct labor. So price is in direct labor cost per unit times it's going to be, so the cost of direct labor is going to be based on, let's say, production. I'm producing 25,000 units, so I could consider that. And I think that's a good way to do, because when you spend money for people, you spend money not based on demand, not based on quantity sold. You spend based on how much you produce. I assume that inventory at the beginning is zero. At the end, I will build $25,000 purses. So I would put here supply, or in other words, inventory build up, inventory difference between time zero to at the end of the year. Accounting point of view, this may not be the case. You can only show maybe an income statement how much money you spent for quantity sold. But again, this is more business point of view, that how much money I really spent to produce 25,000 units, because I start my year at the time zero, this brand new product, zero inventory. All right, so I don't know this because it's a random number, but I do know this 25,000. So I need to calculate really price, direct labor cost per unit, which is based on random number, based on custom discrete distribution. All right, so now how am I gonna do that? So to be able to do this, I need to calculate my lower and upper bound for probabilities. So lower bound probabilities, upper bound probabilities. So my lower bound will be starting with 0, and then my upper bound will be always lower bound plus the corresponding probability. And my other lower bounds will be previous upper bound, so that when I generate a random number, I want to make sure that random number fits within one of those brackets or bins. So now what I can do is just drag this one down and drag this one down, and you can see that I have to press F9 to refresh my numbers. So you can see that I start with 0 to 10 is going to be the first bracket, 10 to 30%, second bracket is $44, and 45, 46, 47. So 45, 46, 47. So I have 1, 2, 3, 4, 5, 6 brackets. I should not have this one. And I have 1, 2, 3, 4, 5 brackets. Let me just double check. 2, 3, 4, 5. Exactly. So now I need to put here cost per unit values associated with it. So what I'm gonna do is reference this and then drag it down. So now I can generate random probabilities, and then based on that, I can read from this table and come up with the price or cost per unit for direct labor cost. So what I'm gonna do is use VLOOKUP, which is vertically lookup. I would like to look up a value of random number, which will generate the value between 0 and 1, and compare that value with these thresholds. And then based on that, I'm gonna get 1, 2, 3, column 3 numbers. So I just need approximate match, because whenever number is between these two, I wanna get the first row. Between these two, 43, and so on. All right. So it looks like These numbers are not refreshed though. I will press F9 a few times to make sure that my numbers are refreshed. So as you see now, the probabilities, cumulative probabilities, and their corresponding cost per unit. So randomly, when I press F9, I ended up $46. Whenever, of course, I press F9 more, this random number changes. So now, since I calculate price for direct labor cost per unit, and I know quant supply, I can calculate my total direct labor cost per year. Excuse me, which is gonna be this times this. All right, so you can see now that that's also a random number. Okay, so now I'm done. I know this, I calculate this. Now I deal with parts cost. So let's go to step number 8. So the parts cost is based on uniform continuous distribution. All right, so since this is uniform continuous, I cannot use rand between. Rand between will give me the integer version of it or discrete version of it. So this wouldn't work because this would only give me values that are exact integers, but that's not my point. I would like to have continuous numbers here. So to be able to do that, instead of using this, what we do is we get the lower bound plus we multiply it with random number between 0 and 1 and the range 100 minus 80 in this case. So that would generate a number between 100 and 80, and it could be any number. All right, so it looks like 9849 for my random numbers. Of course, your random numbers will be different than mine. If I press F9, these numbers will change as well. So, okay, so now this is part cost per unit. Maybe I should do this per unit. However, I don't want per unit. Maybe I should drag this one down a little bit. It's an extra step. So I would like to have parts cost total per year or total. So this is gonna be dollar per year. This is, by the way, per unit, and this is dollar per year. This is per unit. So I can calculate now that it cost me this much per price per unit times the quantity I produce is 25,000. So again, the assumption here is that not an assumption really. It's I want you to see that this is a variable cost. So it's easy to really cheat on this. So this, whenever you see price, variable cost is price times quantity. In this case, price is really price or cost per part. Per I don't know, per part. And then quantity is not quantity, so not demand. I would say quality, supply, or produced, or inventory in this case. Okay, so so these are helpful for you. See this whenever I give you cost per unit, those are variable costs. Whenever I give you per year, those are fixed costs because they don't change based on number of units produced. All right, so I'm done with parts cost. I'm done with labor cost, and I know the admin cost, so I can calculate my total expense right here, which is gonna be this plus this plus this. All right, so this is my reddish number, the sum of my all the expenses. All right, now I calculate my total expense. I know my total revenue, so I can calculate my total profit, which is this minus that. All right, so now I calculated my profit based on these numbers. So what is next? So what's next is that since whenever I press F9, my numbers do change. What I would like to do is I would like to run the simulation for so many times so I can understand overall what is going on in my model. So that's why I will create here a excuse me, simulation section. And let's say I would like to run this simulation for 1,000 times. you have to run it for so many times, like, so that we can see the big picture here. I will do 1,000, and I will give you an exam or homework how many times. So to run a simulation, we always start with the trial number. So I will always leave one cell empty. This is one-way data table, so I put 1 here, and then click on that, home, fill, series, and I would like to have my numbers in my column, increase 1 by 1, and go all the way till 1,000 trials. Click OK. Now the second column here is whatever I'm interested in. In this case, I'm interested in profit. So profit is my output. So this is my input, which is located in my column, and this is my output. That's why it's one-way data table, because I have only one input. So profit calculation, I need to tell Excel how to calculate it, which is right here. This cell knows how to calculate, so I can reference it here. Now I start from the empty cell, Control Shift right arrow, Control Shift down arrow, Control Shift down arrow again. Then I can do data, what if analysis, data table, and I don't have a row input cell because this is column input cell. The column input cell is not really any parameters here, it's just the dummy number, so I just need to choose an empty cell. So I will change something in Excel, and changing that something, that cell, will change all the random numbers in my model, which will give me new results, and I will just keep printing those results here. So I just click over here. What this will do again is take the 1, plug in here, so that's the first element. That will change all the random numbers here. That will give me new results, and print it here. Go to next row, plug 2 into this empty cell. That will generate new random numbers, calculate the objective, which is profit, print it here, and so on, 1,000 times. All right, so you can see now these are your 1,000 results for this model. All right, so I need to press F9 to make sure that my numbers are calculated. Okay, you can see different numbers here. Perfect. So now I need to summarize this by using descriptive statistics. All right, so what do I mean by descriptive statistics? So I need to look at the idea of what's going on in my data. To summarize this, because there are 1,000 numbers so hard to see, I need to calculate the profit values. That's what I'm interested in. That's my model output for mean or average profit or mean profit. I would like to know minimum profit. I would like to know maximum profit. I would like to know return on investment. I would like to know probability of losing money. That's my risk. All right, so let's start with the average profit. Basically, I type average and then take the average of these 1,000 results. Control Shift down, press enter, and now looks like on average I'm losing money, right? Yeah, for given numbers. What I can do is now so what I can, let me just do this. Let me just, if I plug in here 125,000, does it change anything? Okay, I still lose money. So it looks like I'm losing money. I just want to make sure that I don't have any typo here. So profit is revenue minus expenses. Revenue is price times quantity sold. Quantity sold is the minimum of supply and demand. Demand is random number based on normal inverse function, mean and standard deviation. And I round it and make sure it's not negative. And I add up all the costs, 1, 2, 3. Direct labor cost is going to be per unit cost times the inventory, which I spent so much money on inventory, it looks like. And I look at the labor cost per unit based on this table, and then I calculate my parts cost, which is going to be based on a random number again. Again, I multiply it based on the quantity produced. So as you see, 25,000 production is a lot of production. So if I go, let's say more 15,000, probably I will be more profitable. Press F9. So as you see, I would make money if I just produce 15,000 around average demand. But if I go with 25,000 here, if I produce so much, basically, I will start losing money. Okay, so now let's take a look at the minimum of these values. Control Shift down, press enter. So it looks like I can lose $4.3 million. Let's look at the maximum to see whether I can make any money. Do I have any hope? All right, so it looks like yes, I can make $2.1 million based on the given parameters. So what's my return on investment on average? So average return on investment is, this is the return. I'm assuming that to be able to produce this person, you spend $1 million down payment or upfront cost. So it looks like the return on investment is horrible on average, negative 64%. So it's a horrible investment. So what's the probability of losing money? So to do that, I need to do count if, look at the range, Control Shift down arrow, and to make sure that you check whether this number is less than or equal to 0. So I put less than or equal to 0 in quotations because this is not a number. I need to tell Excel to not freak out. This is the logic, and divide by number of trials. In this case, I have 1,000 trials. So as you see, probability of losing money is 72%, pretty high. All right. So now this is my base scenario, base simulation scenario. So what if I change my model to something more realistic? All right. So what if I'm trying to decide on the way it is what I'm trying to decide is, hey, should I launch this new product or not? And looks like based on this price, nah, I don't want to lose money on average. Nah, return investment on average negative. Nope, I don't like to lose money with 72% chance. So let's see whether we can make it better by playing with the price. Okay. So now let's look at the best price question. So what's the best price so that can I make money? I just control drag, create a copy of the same sheet. So you can collect this data from your customers, or you can ask your top executives or marketing department with so much experience, say, hey, if I charge instead of $249, if I charge $100 or $150, or I will highlight these two and drag it down, say up to $400, would it make any difference? Let's actually choose a even bigger range. So let's choose 50, 100, 400, up to $500 for person. So literally double of base price to really pretty much 80% off. So I'm wondering whether this could make any difference. So now you'd ask your executives or customers, hey, if I decrease the price from 249 to, this is 250 or 249 is pretty much same. Let's say this is 15,000 on average demand based on normal distribution. However, if I change my price for these purses from 250 to 200, would you demand more? Unless probably so, right? Because it's cheaper. Let's say they say, hey, probably the sales will be around 20,000 units then on average. So these are all units, not dollars. These are all number of units. Okay, so now what I would like to do is I asked this question: if I give even further discount, 150, how many do you think they will buy? 35,000 on average. Okay, what if I go to 100? Let's say 80,000 units. This should be given to you in test, but in real life you need to get this data from your managers or customers. And let's say, what if I charge 50? Oh, everyone will go crazy, and let's say 150,000 people will buy your product. Okay, so now what I can do is try to figure out what would happen if I increase the price. So let's say they say 12,000 units, 10,000 units, and then here let's say only 6,000 units, and anything greater than 400, let's say 0, no one would buy my products. Okay, so now what I would like to do is I would like to find the best distribution for this. Maybe I should just not, let me just, instead of doing this, maybe what I'm gonna do is, so this including this two, what I'm gonna do is I would just include these two and to see what's going on. All right. So what I'm gonna do is I will insert, because these are zeros, so I want to put if statement whenever the price is greater than 400. I would assume that I will not be able to sell anything. So insert, and you will see here a scatter chart. All right, so this is your data, basically. This is your chart, and this is literally your demand versus average demand, average demand versus price. So let's add the excess tiles quickly. So this is your average, this is your demand in units, average demand in units, and this is your price per unit. All right, now I can try to find the best line that fits with this dot. So if I click one of those, you can, and then right click, and here add trend line. So you have a bunch of options here. When I use linear trend line, let's see what's the equation and what is the R square. So look at this. So if I use linear line, which is this one right here, maybe I should color code it better for you guys. Let's use a different color here. Let's say purple, and let's make it even thicker here. All right, so if I use this linear line to explain these blue dots, basically I can only explain, as you see, 69% of the variation in my demand changes by using this line based on price per unit. It's not horrible, but it's not the best. As you see, slope is negative, which means that the higher the price, the lower the demand. Let's see whether if I try exponentially that I can improve R square. All right, wow, that's beautiful. You see, this is like 94%. So this is beautiful. Instead of 69%, you go to 94%, or you can explain the variation in your demand with this purple line. So that's pretty cool to me. That's a logarithmic, not that good. I mean, it's good, but it's not as good as exponential. Polynomial, actually, it's pretty good. I could use also polynomial. Sounds like 9481 versus 9439. They are very similar. So I guess in this case you can use either one of them. But this assumes that the demand starts going up after 300 price, because I guess people think that the purse is pretty cool. So that may be the case actually. So which one should I use? If I go power, it's 98%. Wow, this is excellent. So maybe then I should just use the power function, because this is explaining pretty much 98%. Okay, let's stick to this because it's better than anything else. So again, I can explain almost more than 98% of variation in demand by price per unit using this power function. All right, so what I'm gonna do is take this function, which is a beautiful function, and plug into the demand, average demand, because I know that it's not gonna be 15,000 anymore. It's going to be this number. Again, this means 7 to the power 10 to the power 7, so it's a pretty big number. All right, so what I need to do is now replace this x with independent variable. So I will say times x, which is your price, is independent variable. That's what you put in your graph. X is your price per unit. All right, so now this will give you, oh my gosh, so this didn't work, because I guess there is a problem here. Oh, I see what's the problem is. This is not negative 1.5. This is power negative 1.5. You see, x to power negative 1.54. Okay, copy this. So actually this is gonna be the power negative 1.54. Okay, that makes more sense. So average demand, as you see here, for price of 250, 249 is 14,000 units on average. I'm assuming the standard deviation doesn't change. So what if I go to, let's say, price of 400, and then you see the average demand went down to, I charge higher price, went down to actually not much, right? So when, let me just press F9 to refresh my number. 68. Actually, it went down a lot from 14,600. I was expecting somewhere around 6,000. So let's see if I go very cheap, $50, and let's see what's gonna happen. I'll press F9 to refresh my numbers. You see, I get crazy demand. All right. So this is beautiful. So based on the price change, now my average demand does change. Based on that, my quantity sold does change. And then based on that, my profit does change. So now what I can do is run the model for different prices to see what's the best sold best price. So to do that, I need to do two-way data table. So what I'm gonna do is I'm going to delete all these. Maybe I would just delete all, let me just delete these two, highlight, press delete. And what I'm gonna do is I would like to calculate for all the price options that are provided here. By the way, I need to make one more change here because I wanna make sure that the price, the demand will be 0 after 400. So if the price is greater than my threshold that's given here, 400, if it's greater than 400, then give me 0, otherwise the value that we just came up with. All right, this is more beautiful, so that if I try to charge, let's say, so much money, $500, I should F9 to refresh, I should sell nothing. Perfect. So now what I want to do is I would like to consider all these scenarios, which I created 10 scenarios here. I need to have 10 columns plus the trial number. Let me just insert some more columns here. All right, let's insert a couple more. Perfect. I don't need to highlight these. Let me fill this with nothing, no fill. All right, so now, again, in my first column, I will have my trial numbers. All right, so let's say I want to again run this model for, let me just pull this one a little bit down because I know that I will need some space for my calculations. So let's say I create the trial numbers here. And let's, at the top, what I would like to consider is, let's say I would like to consider the mean and ROI. I mean, I don't really need ROI. Let's calculate mean and probability, okay? So I will just do mean and probability of losing money. So let's, I don't need this section. I could just delete this directly. So let me just calculate the mean and probability of losing money, okay, for all the price options. So I will just copy these, Control C, and then paste it here, paste special, and I will get values and transpose. Okay, so these are the price options that I have. All right, so I'm wondering what would happen if I charge this much. All right, so they don't need to be red really. Okay. So these are my price options. So my trial number will start from 1, and then home, fill, series. I would like to have my numbers in my column, increase them one by one all the way up to 1000, and then click OK. So now these are my trial numbers. Now I can calculate in the top left corner my output, which is profit. I need to tell Excel how to calculate it. So that calculation is right here. So now I have that value as well. So as you see, I'm losing money if I charge $500, $4.2 million actually on average. So now I can run this model 4,000 times for different prices, Control Shift right arrow, Control Shift down arrow, data, what if analysis, data table. Row input cell will be price. And then column input cell will be trial numbers, which is a dummy number. So I will just choose this blank cell, let's say this one, and I will keep that blank all the time. Click OK. So now I got all these runs, and these are all dollars. They don't need to be bold. Control B, and they don't need to be red. It looks like these numbers are a little big. Okay, so now I can calculate the average return for every single price combination. All right, so what I'm gonna do is I will take the average of this column, and looks like I'm losing money on average here, and then right here. Now press F9 to refresh your numbers. Okay, so no matter what I do, really I lose money because probably my inventory level is not right. And then probability is, let's say, count if the range is from beginning till the end, Control Shift Enter, comma, if this is less than or equal, let's say less than 0, that means I'm losing money, divided by number of trials, which is 1,000. All right, so these are going to be probabilities. Okay, so if I just drag it right, wow. Okay, if I press F9 so many times, so what's going on here? So it looks like no matter what I do, based on this, I'm not making any money. All right, so what if I change my inventory level to fix with the average demand? So let's say my company policies produce as many as I expected on average. Then this new inventory policy can change things up a little bit. All right, so what do I see here when I press F9 so many times? So now let's color code these numbers because they're harder to read right now. So what I'm gonna do is let's make them black. What I'm gonna do is I will highlight this and then home, conditional formatting. Let's use the green as the best number and red is the worst number. And then same thing here, but this time the lowest number is the best number. So what I'm gonna do is conditional formatting, color scales, the best number, which is lower. So lower will be green, higher will be red. So now if you look at the average return on investment, which is the first row, the best solution is basically go with $300, or charge $300 your customers, and you will make on average $242,000, which is not too bad. If you look at ROI point of view, this is 24.2% return on investment. If you divide this value with initial investment of $1 million, admin and marketing expenses, 24% is pretty good. And if I look at probability point of view, again, the best solution is 300. So if I charge 300, there's a 28 chance of losing money. It is a little bit high, but not horrible. And the mean price is the best also, 24%, which is a great return on investment. So how can I decrease probabilities in the future? If it's a managerial question, you're gonna make sure that either you invest less money or you produce things more efficiently in terms of labor costs and parts costs. That's it for this video. Until next video, enjoy business analytics.